Hello, welcome back to the continuing lecture in investments. So, in our last class, we actually found the minimum variance weight, right? The weight of the bond and the weight of the stock in the risky portfolio that would minimize the variance of the risky portfolio. And as I actually plotted and graphed uh, the the minimum variance frontier. I mean uh, the the portfolio frontier, right? It's called. It wasn't really a smooth, a line, and there was a segment that was not smoothly and seamlessly continuous. And I was wondering why. Um, and I realized that the initial data was wrong. And as I looked back at that video, I noticed that the expected return on stock was 15%, and on 19%, 19%, and uh, the standard deviation was all wrong. And why? Why did it happen? Well, I don't know. Wherever I took the numbers from, those numbers were just out of nowhere, because these numbers must be based on our uh, previous portfolio construction, because in our previous because this example is all related. I mean, it's the same example, just going through um, uh, phases, right? Different phases. So it's the same example, same portfolio, and in our original portfolio, right? The stock mean return of the stock was 10%. Mean return of the bond portfolio was 5%, and the standard deviation of the stock portfolio was 18%, and standard deviation of the bond portfolio was 8%. Stock was 18.6 point. So instead of, but those numbers were all just somehow, arbitrarily, uh, typed in there, and that is, we don't have to, we don't type it in there, because we know we can do better. I mean, I just, simply uh, point to, after equal sign, I point to this cell, right? Which is, in other words, that's what it is saying there. 6.2 is the name of the label, right? Of that worksheet, the bottom tab label. So it's, basically telling you it's in, bottom tab label 6.2 D7, right? And I did that for all of them. It's in, H7, cell H7 of, worksheet with the bottom tab 6.2 worksheet. And the standard deviation 2, this 2, right? And then you might wonder, oh, what about wasn't the correlation negative 0.49? Yes, that was our correlation, but uh, the textbook used more realistic and empirical uh, correlation. So this was entered manually, right? 0.2. Okay. And if you remember, let me quickly, let me just, see if we go back to all right, by now you should be able to see that. Okay, it should be see that a realistic correlation coefficient between stock and bond based on historical experience is actually about 0.2. So we used, right? We used this number. Right? And that, what was that spreadsheet? That example spreadsheet 6.5, right? That was what was used in spreadsheet 6.5. Okay, I don't think I will need to spell out everything, right? You would understand. Spreadsheet. Just abbreviations, 6.5. That's what was used there, right? Okay, so again, switching back to the Excel, you should see it just about now. Okay, so as soon as I corrected these numbers, and everything automatically, corrected itself. So, and then the graph also corrected itself. Now it looks more like it. And this is the minimum variance. And then the number is in order, these numbers, weights are in order, because previously it was just out of place. Suddenly, why? Suddenly, 0.3, it was like, 0.3 something. I mean, if it is 0.3 something, then it should have come here, right? It should have come in this row, not in that row. It was suddenly out of place. And this is the minimum variance, because our variance look at the standard deviation calculation. And in terms of variance, of course, this is also the lowest, right? And in terms of standard deviation, it's also the lowest. And look at, so this is the horizontal axis, that's the standard deviation. You can tell nothing is lower than, in terms of standard deviation, no point along this frontier, right? Along this frontier. No point is lower in standard deviation. Of course, just because the standard deviation is the lowest, it doesn't mean the return is the best at that point. No, the return isn't the best at that point. The return is only, at that point, the return is only like 5.53. Okay, then where is the best return? Of course, as you go further this way, the returns are higher, but then the risk is also increasing, right? And the mean variance ratio would fall, right? So actually, we're going to be talking about that, but uh, what is Sharpe ratio? Sharpe ratio is where you know, the slope, um, the tangency line, which is slope, right? Where the slope is the maximum, right? And then I also calculated here as well. Uh, this would be the where it would happen, the maximum Sharpe ratio. But then that will be another story. So we're gonna continue working on this example first. So what if, let's try different scenarios, right? Different scenarios. I also okay, here. I hope I didn't. Okay. I copied, not numerically copied, but you see what I did. It's pointing to A2, so that was the number that was, also referring to the original data, right? So I'm not going to make any further mistake like that. Yeah. So given these data values, right? This is the correct data value. What if we have different correlations, right? Of course, this is the realistic correlation. I mean, empirically, that's the historically the empirical correlation. But what if the correlation is -1, 0, 0.5, and 1? Well, it's excuse me. Well, it's the same thing, I mean, under all of these different weights, if the weights are like this, and we know uh, if the weight of the stock is, -1, then the weight of the bond will be minus this thing, right? It will be, right? Makes sense. That means you're shorting stocks and putting everything in the bond, right? And like this. If this is the case, then what is weight of 1 plus 1 in stocks? It means you're shorting bond. In other words, selling. I mean, borrowing. Selling bond is borrowing money, right? And then putting all that into stock. I'll take care of the housekeeping, the borderlines. I need borderlines like that. And of course, we know what is the expected return. It's exactly the I can copy, what I did there, like this. Copy. Oh, no, 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 no. Standard deviation. Okay. That's fine, standard deviation. So what I did here, 829, that shouldn't be 82. It should be 826. B26. And I will lock B26 and B26. So A26 and B26. Okay. B26. Hit enter. And what about this? A29 times, so let's see, 26. A26, I'm going to learn. And times, A29 bit weights, right? A29 B29, and then what is this going to be? This time, yeah, the correlation between the two. Or oh, we don't have covariance here. I'm sorry, we don't have covariance. That was covariance previously. We don't have covariance here, so we'll have to. What can we do? Yeah, 8 weights, and then so we'll have to covariance by applying standard deviation of x, standard deviation of y, and correlation between x and y. And I'm going to have to lock all of those. Okay, so that we'll lock that one. Okay. All right. And this is our B29, C26, B29, C20, D26 squared, right? Times A29, B29, C26, D26, and correlation, right? And then this is the variance. I mean, if this is the variance, then square root of that is, standard deviation. So now we are ready to kind of light color here. So let's see. I'm gonna write it down. There you go. I'll give it a light color. Very light color. Something like this. And now let's think about where is the minimum variance? And minimum standard deviation. The minimum standard deviation is this one, isn't that right? If the correlation is -1, the minimum standard deviation, I'll make it a slightly darker, slightly. Yeah, there it is. And then the weight between stocks and bond would be this, right? And then I do the same thing when correlation is 0. So then all I need to do is simply copy this, paste it there, and make sure I'm pointing to the correct correlation. And the correct correlation here is this. And I'm going to lock it. Right, let's do. 9026, that was F26, okay? All right. There you go. I'm going to drag it down. Okay. And what do you see? And in this case, which one has the lowest variance? Something's this has the lowest variance. Let me just make sure. Previously, the lowest variance is here. C29. Oh, it's pointing to the wrong. So the weight is here, right? Weight is here. The weight is there, and C26, B26, F26, yeah. And then drag it down. Okay. And which one has the lowest variance? Right, when the weight is 0.2 for stocks and 0.8 for the bonds. Okay. And again, continuing with that, I'll have to make, I'll have to make adjustments, as I go along. But it may seem tedious, but not a big deal. It's much easier than making doing it one by one. Yeah. Okay. It's been copied, but let's just make sure it's pointing to the correct cell. Okay, the weight is A29, and then A29, again, A29, B29. And the correlation is in each 26, okay? There you go. Now I drag it down. What do I see? Where's the lowest, variance? This is the lowest variance. I mean, it's not variance, it's standard deviation, but either way, that means also the variance is the lowest, Okay, minimum variance. Put this, find, exercise to find the minimum. And that happened when, and this is under the scenario where the correlation is 0.2, and it matches our. Wasn't it when when we did this? Wasn't it when correlation is 0.2? Yeah, you got that right. You got that. But of course, you might say, "Oh, that was 8.025," but why is it 0.8.026? Well, because our weight isn't as precise as that. Our weight is just 0.1 and 0.9, whereas here weight is 0.1062 and 0.8937. And how did we get this weight? Because we found that weight by this formula, right? This formula, right? But here, without that formula, we just, this is kind of, whole, trial and error method, trial and error, right? And we are as close as we can. We are as close, as humanly possible, right? Without using technology, humanly possible, without using math, everything is, technology and math, but, we found, of all these, we found the minimum variance, right? And continuing with, now, what if the correlation is 0.5? Let's see, and let's make some adjustments. Again, it's 829 and B29, right? And A29, B29. And where's the weight? In J26. So make that adjustment and we drag it down. What do we get? Again, and our minimum variance is found exactly here, where the weight is 0 and 1. Okay, if the correlation is 0.5, then you shouldn't put any into stock portfolio, put 100% into bond portfolio. Okay, now what about here? I still have that. Okay. When the correlation is 1, that means they move together, they move in tandem, or they move in, exactly in the same, by the same, magnitude, same degree. So let me copy that and paste it here. And let's also make that adjustment. This is A29, right? This is B29. And this is, again, A29. I can also, interesting thing, I can also lock only the column, right? So that, doesn't really. And our correlation is in L26 now. I hit enter and I drag it down. What do you see here? If the correlation is 1, right, the minimum variance is achieved, right? This is the minimum variance, minimum standard. Minimum variance is achieved when you short the stock and put, 110% into the bond portfolio, right? Oh. Well, I'm not going to, then, what did I do here? If we use the, okay, it's basically what we've done, but, if we use, minimum weight, right, formula, and find, return and standard deviation of the portfolio, right? Under these, correlation coefficients, right? What's it going to be? So, actually, let me quickly do that, So, it's going to take just a little more time, and I'm just, concerned that we may be we are already running out of time. So, Since we are there. I'll just let's see. I'll just copy and paste what I did up there and just to make some adjustment. So first thing, to find the weight, so it has to be, the weight of stock, right? And that's the formula, the formula is, weight of stock squared, which is, 826, yes. And that weight of stock, that standard deviation of stock squared minus standard deviation of stock, standard deviation of bond, and the standard deviation of bond is not we have a little here. Now this is not okay. This is not weight of bond. Previously weight of bond, but this is weight of stock. So then I should be doing the opposite, weight of so that should be weight of bond, and D26 is weight of bond. Okay, and then standard deviation of bond, and then standard deviation of bond stock, and then correlation, which is where is the correlation for E26, and then weight of bond squared. Standard deviation of bond squared. Standard deviation of stock squared, and minus 2 times standard deviation of bond stock and correlation. So we got that right. So that is the and the weight that goes into the stock, and that the weight that goes into the bond is 1 minus that, right? So we have and E43, that is the weight that goes into the stock, and A26 is the stock. A26 is what goes into the stock, the expected return on stock, and then 1 minus E43 is the weight that goes into the bond, and B26 is the expected return on the bond. We got that right. And then standard deviation of the portfolio is weight of stock times sigma of standard deviation of stock square, right? 1 minus E43, that's the weight, and this bond standard deviation squared, plus 2 times, yeah, okay, correlation times, weight of stock, weight of bond, standard deviation of stock, and standard deviation of bond. I don't know why I didn't lock E26. E26 is the correlation. Where is the CN 26? What is E43? E43? There is no E. Oh, that's the optimal weight, right? Optimal weight. Yeah, okay. And what is E26? E26 is the weight correlation, okay? So there you go. Okay, if the in this case correlation is 0, -1, so standard deviation of the portfolio is, if the correlation is 0, if the correlation is 0, the standard deviation of variance of the portfolio is actually 0. That's correct, because when there's no correlation, that means they canceled out. The variance of stock, variance of bond have canceled out each other, right? So this is only natural. Then I will just replicate this all over under different correlations. I mean, we are already out of time, so I cannot continue. I will have to cut off the video at this point, but the rest of it is simply replicating this under all different correlations. Okay, that makes sense? Alrighty, so then I will see you guys in the next video and stop recording.